He claims that CERN destroyed the universe during recent experiments, which has resulted in us living in a nearby parallel universe.
CERN is the LHC, the Large Hadron Collider. It's the largest machine in the world, located in Switzerland, and it's all underground, and it uses this gigantic track, this underground tube that's connected, and they send atoms in opposite directions and speed them up to a percentage of the speed of light and then let them collide. And then they analyze the collision to see what comes out of this collision between atoms, quarks and muons and everything else that they discover. But something else they discover in the process is that they create microscopic black holes.
For many years, scientific exploration has been exceeding expectations and surpassing barriers. From the creation of the Large Hadron Collider and James Webb's Space Telescope to discoveries like the Higgs field and the Higgs boson, scientific advancements can only get better. While the world is facing news of an impending Third World War and struggling amidst the serious famine in many countries, the European Council for Nuclear Research has broken its silence on a very chilling discovery that just might change everything we know about antenna and outer space. To make matters worse, there is the belief that the discovery is only the Mandela effect, and it probably doesn't really exist. But what if it's actually true? What is this scary discovery, and why are scientists very worried about it? Sit back as we take you through all that has been happening at CERN recently. The CERN and what they've discovered. CERN, also known as the European Organization for Nuclear Research, is a place where scientists do amazing experiments. It's been around since the 1950s and helped us understand the universe better, but some people are concerned that these experiments could create things like black holes or mess up our reality. One of the most famous things that CERN has made is called the Large Hadron Collider, or LHC for short. It's the biggest and most powerful machine for studying tiny particles in the whole world. The LHC started working on September 10, 2008, and it's still one of the most amazing machines scientists have ever built. The LHC is a big circular tunnel that's over 27 kilometers long. Inside the tunnel, some special magnets and devices help speed up particles. Building the LHC cost more than $4.5 billion with a production budget of $9 billion. One of the more shocking things scientists found with the LHC was something called the Higgs boson. This tiny particle helps explain how other particles get their mass. The LHC has also helped scientists find lots of other particles that they didn't know about before. All these discoveries are helping us understand how the world works better. Here's how the LHC works. Scientists speed up different particles and then make them crash into each other with a lot of force. The LHC can make particles go very fast, almost as fast as light, and they go around the circular tunnel more than 11,000 times every single second. Despite its groundbreaking discoveries and contributions to our understanding of the universe, the experiments conducted at CERN, particularly those involving the LHC, have raised concerns among people across the globe. The fear of unintended consequences, such as the creation of miniature black holes or the disruption of the fabric of reality, has led to debates about the risks associated with CERN's experiments. But scientists at CERN continue to conduct research responsibly, taking into account all safety measures and regulations to ensure the protection of their experiments and avoid adverse effects from affecting the world at large. The Large Hadron Collider is a massive machine that scientists use to study tiny particles. It works by speeding up these particles fast and then smashing them together. To speed up these particles, the LHC uses something called electromagnets. These electromagnets create a super strong magnetic field inside the machine. In fact, the magnetic field inside the LHC is almost 1,000 times stronger than the Earth's magnetic field. Now, all this power might sound a bit scary, especially for things like electronics nearby, and even the Earth's own magnetic field. Some people worry that such a strong magnetic field could mess up electronics or even affect the Earth's magnetic field. Once these particles inside the LHC reach their top speed, they crash into each other with high force. When this happens, it releases a huge amount of energy and creates all sorts of different particles. When these particles eventually crash into each other, they shoot out in all different directions. But most of these particles only last for a tiny, tiny bit of time before they disappear. To find out what happens when particles collide, scientists have put these super-sensitive detectors all around the places where the collisions happen. These detectors are like super-powered cameras that record everything that happens when the particles crash into each other. But here's the thing. All this smashing and crashing creates a massive amount of data. Every year, the LHC produces more than 15 petabytes of raw data. Sorting through all this data takes a lot of time and effort. In 2017, the LHC reached a very important milestone. It stored more than 200 petabytes of data in its tape libraries. This means scientists can study all the data from the LHC's experiments in very fine detail. To help you understand just how much data the Large Hadron Collider generates, let's put it into perspective. Imagine 1 petabyte of data. That's like having around 250,000 movies, but why do scientists need so much data? Well, they're looking for something very special in all of that information. You see, scientists detected something strange happening with a tiny particle called a quark. Quarks are like the building blocks of everything around us. They come in different types, which scientists call flavors, but some of these quark flavors are very unstable. They quickly change into other particles. One specific type of quark, called the beauty quark, caught scientists' attention. This quark is supposed to quickly change into 2 different types of lighter particles. But when scientists looked at the data from the LHC, they found something surprising. The beauty quark didn't always change into those 2 lighter particles as expected. According to the standard model, which is sort of a big rule book for how particles work, the beauty quark is typically meant to change into 2 different particles about half of the time. But the data from the LHC showed that it didn't. Instead, it changed into one of the particles, called a muon, much more often than expected. This unexpected result got scientists really excited. They think it might mean there's something new and exciting happening in the world of particles. The standard model of physics, which scientists have been using for a long time, might need to be updated. This could help answer lots of questions that scientists have been wondering about for a long time. The standard model is similar to a guidebook to understanding how everything in the universe works. It tells us about all the tiny particles that make up everything around us. But if there's something new out there, something that doesn't fit into the standard model, that could change everything. So the data from the LHC isn't just a bunch of numbers. By studying this data, scientists might uncover new secrets about the universe and how it works. It's an exciting time for physics, and who knows what amazing discoveries lie ahead. It's pretty amazing how accurate the standard model of physics is. Scientists have used it to understand so much about how the universe works, but even though it's really good, there are still some things missing. The standard model only tells us about 3 of the fundamental forces in the universe: the electromagnetic force, the strong force, and the weak force. It doesn't explain gravity, which is what keeps us on the ground, or dark matter, which makes up most of the universe. During recent experiments at the Large Hadron Collider, scientists found something that didn't fit with what they expected. This happens sometimes, but this time, it was very interesting. There was something different about the data they were looking at, and scientists wanted to find out what it was. To explain this strange discovery, scientists came up with a new idea. They think there might be a whole new basic particle out there that we've never seen before. They call it the Z prime. This new particle would be weak, so weak that we've never noticed it until now. But even though it's weak, it could still interact with other particles in a different way than we're used to. The researchers think that the Z prime particle might interact differently with electrons and muons, which are 2 other tiny particles, but they're still not sure how it would interact with all the other particles that we already know about. There's still a lot to learn about this new idea, and scientists are excited to keep studying it. So even though we've already learned a lot about the universe, there's still so much more to discover. Possibilities of discovering new force-carrying particles, and Elon Musk's opinion. Discovering new particles that carry forces would be life-changing in the world of physics. It's something scientists have been hoping for a long time. If they find these new particles, it could help them understand a lot of things about the universe that they don't understand yet. For example, they could finally figure out what dark matter is, and they could learn more about the Higgs boson, which is very important in how the universe works. Some scientists think that if they discover these new force-carrying particles, it could help them do something really important: unify all the basic forces in the universe. That's something that physicists have been trying to do for 100 years. Elon Musk has had some interesting things to say about all this. He recently talked about the Large Hadron Collider. It's not clear if Elon is really adding to conspiracy theories or just joking about them. The billionaire has used X, formerly known as Twitter, to talk about CERN's demonic technology. We all know Elon Musk is a forward-thinking leader in science and technology. For many years, he has been very interested in tech that could change the world. He likes trying new things and isn't bothered by criticism that comes his way. But what we don't know is what Elon has in mind to do. In his post on X, he didn't say what he plans to do with the collider or why he wants access to this CERN technology, which is super important for quantum physics. Lots of people on Twitter talked about his post. Some asked him questions like, what's stopping people from living on Mars right now, but he didn't answer. We can understand why Elon thinks the machine is demonic, seeing as it took more than 10,000 scientists, hundreds of institutions, and laboratories from more than 100 countries to build it. The Large Hadron Collider is underground, about 175 meters below the ground, right on the border between France and Switzerland, near a city called Geneva. The first time they made particles smash into each other at the Large Hadron Collider, it was mind-blowing. The energy from the collision was 3.5 trillion electron volts for each beam of particles. That's like 4 times more energy than any other collider had ever made before. Later on, they made it even stronger, with energy reaching 6.5 trillion electron volts per beam. That's not all. The Large Hadron Collider is great at making particles called protons smash into each other, but it can also make other particles called lead ions collide. Every year, scientists use the Large Hadron Collider to do experiments to test out different ideas about how the universe works. They study what happens when particles smash into each other, and they use that information to learn more about the universe. You should know that scientists are doing a lot of experiments to learn more about a particle called the Higgs boson. They're also looking for other new particles that they think exist based on what they know about the smallest building blocks of matter. These particles are called hadrons, and they're made up of even smaller particles called quarks. Quarks are held together by a force called the strong force, kind of like how atoms and molecules are held together by another force called the electromagnetic force. Protons and neutrons are examples of hadrons that we already know about. Some other examples are particles called pions and kaons, which were discovered in experiments with cosmic rays back in the 1940s and 1950s. You can think of the Higgs field as kind of like the sea, and the Higgs boson is like a ripple in that sea. Scientists found it at the Large Hadron Collider in 2012. They used 2 unique experiments called ATLAS and CMS to find it. They announced their discovery on July 4, 2012 at CERN. They found the Higgs boson by studying 2 rare ways it decays or falls apart. One way is when it turns into a pair of photons, which are particles of light. This process is very special because it's a purely quantum or very tiny process. But even though they found the Higgs boson in 2012, scientists didn't stop there. They kept studying it to learn more about it. One really important thing they found out is more about how the Higgs boson falls apart, or decays. According to CERN, they're going to keep studying the Higgs boson, especially after they finish making some big upgrades to the Large Hadron Collider in 2029. When the Large Hadron Collider gets these upgrades, it will be able to do even more collisions. That means scientists will have a better chance of making weird discoveries that don't fit with what we already know about particles. CERN, which is the organization that runs the LHC, says that when they finish updating it, they'll be able to make about 15 million of these particles every year. To put that in perspective, back in 2017, they only made about 3 million Higgs bosons. This could be really helpful because scientists think there might be different kinds of Higgs bosons out there. Some theories say there could be up to 5 different kinds, and some of these might not show up as often as the regular Higgs boson. Even before these upgrades, scientists have found some pretty good evidence for something called a magnetic Higgs boson. But why is the Higgs boson such a big deal anyway? Well, it's all about something called the Higgs field. This field was super important right after the universe was created. It's what makes our universe work the way it does. Without the Higgs field, there wouldn't be any stars or even atoms. There wouldn't be any life. That's why some people started calling the Higgs boson the God particle. The name God particle came from a scientist named Leon Lederman. He actually called it the goddamn particle because it was so hard to find, but the name God particle stuck, and now that's what a lot of people call it. Back in the 1990s, when Lederman wrote a book about the Higgs boson, he wanted to call it the goddamn particle, but the publishers didn't like that, so they changed it to the God particle. This started a bit of a problem because it made some people think the Higgs boson had something to do with religion. That's still something that scientists worry about today, but even though it's got a nickname, it's hard to say just how important the Higgs boson really is. The Higgs boson is part of something called the Higgs field. Without the Higgs field, particles wouldn't have any mass, and if particles didn't have mass, there wouldn't be any stars, planets, or even people. So you can see why physicists get pretty excited about the Higgs boson. Why else scientists are studying Higgs boson? Scientists aren't just interested in the Higgs boson because it's extremely important. They're also studying it for 2 other reasons. First, they want to know how the universe got started, and second, they want to know how the universe stays the way it is. The Higgs field is pretty weird because it gives energy to the space between particles. This energy is what keeps everything in our universe working the way it does. Scientists think this energy is what makes things like the electromagnetic force, which is what makes magnets work, and the weak force, which is what helps some particles decay, work the way they do. To understand all this, scientists need to know how Higgs bosons interact with each other, and to do that, they need to make pairs of Higgs bosons. It gets more interesting. By studying how these pairs of Higgs bosons act, scientists can figure out how other particles get their mass, but the main part of it still needs to be explained. Any balance in the theory doesn't guarantee this mass and causes unintended instability. Quantum fluctuations could disturb the physical vacuum itself. Fortunately, this happens over timescales much longer than the universe's known lifespan, but scientists are still searching for additional Higgs boson-like particles. These particles would indicate the presence of the new physics needed to stabilize the Higgs boson's mass. All these factors encourage the study of much more data and, if possible, access to higher collider energy. That's why, even 10 years later, hundreds of experts around the world remain dedicated to the effort. The Higgs boson was first thought up in 1964, but it wasn't found until 2012. Lots of people who love science wonder why it took so long. The answer is that the Higgs boson is very big and doesn't stick around for long. To make such a big particle, scientists had to smash lots of energy into a tiny space. They needed a big machine called a high-energy collider to do this. After they made the Higgs boson, it didn't stick around for long. It broke apart into smaller bits in different ways, and only a tiny bit of it could be seen against the background. So scientists had to build large and complicated detectors to find these tiny bits. Then, they studied hundreds of billions of proton-proton collisions to find a Higgs boson signature. But will CERN's projects and findings lead to significant discoveries, or will they bring about our ultimate demise? Conspiracy theorists have 3 main hypotheses about what CERN is really doing. The first, and most alarming idea that has led some to accuse CERN, is that the organization is trying to open a gateway to hell. Some believe that CERN's experiments with subatomic particles traveling at the speed of light will take humanity beyond the gates of the ultimate inferno. CERN has stated that the aim of producing antimatter is to gain a better understanding of matter and mass. Wikipedia describes antimatter as subatomic particles with the opposite electrical charge of regular matter. Supporters of the Big Bang theory suggest that antimatter was created during the universe's formation and should exist in equal amounts with matter. But antimatter is extremely rare. Another conspiracy theory that has arisen about CERN's discovery is one that'll really interest you. It involves the Mandela effect. This effect is when many people remember an event differently from how it actually happened. Some conspiracy theorists believe that CERN's particle experiments could cause disruptions in our reality, leading our planet into another dimension, and resulting in a widespread Mandela effect. Lastly, some conspiracy theorists claim that human sacrifices occur on-site at the CERN facility. In 2016, a video supposedly leaked online, alleging that ritual sacrifices were happening at CERN. The footage purportedly showed hooded individuals roaming the CERN campus. It was claimed that the video depicted a young girl being stabbed in the chest by these masked figures. But according to The Guardian, a CERN spokesperson came forward to debunk the story, stating that the ritual was staged as part of an elaborate prank. Whether a police investigation was conducted following this incident remains unresolved. It's no surprise that CERN has long been a target for conspiracy theories. Therefore, when scientists resumed operations on July 5, 2022, after 3 years of improvements and maintenance, it was inevitable that conspiracy theories would once again emerge online. Despite CERN's efforts to promote transparency and scientific progress, its complicated experiments and groundbreaking discoveries often increase speculation and mistrust among certain groups. The concept of antimatter has interested scientists and science fiction enthusiasts alike for decades. The idea that there is a completely different space of particles with properties opposite to those of regular matter is both intriguing and perplexing. By studying antimatter, scientists hope to unlock the mysteries of the universe, from understanding the fundamental forces that govern matter to potentially harnessing antimatter as a powerful energy source. Now, back to the Mandela effect. The Mandela effect, named after when many people remember an event differently from how it actually happened, has become popular in culture and conspiracy circles. While most scientists think the Mandela effect comes from false memories or thinking errors, some conspiracy theorists think that CERN's experiments could mess up reality, making big changes in what we all remember. Imagine you remember a movie line one way, but then find out it's actually different. Or maybe you remember a logo looking one way, but it's always been different. That's what the Mandela effect is all about. It's named after Nelson Mandela because many people thought he died in prison in the 1980s, but he died in 2013. It's basically like lots of people are sharing the same wrong memory. Now, some folks think CERN's experiments could be causing this Mandela effect. They worry that by messing with tiny particles, CERN might be changing the way reality works. This idea might sound far-fetched, but some people take it very seriously. As for the claims about human sacrifices at CERN, they're probably the most crazy and baseless of all the conspiracy theories about the place. When the video was supposedly leaked in 2016, CERN quickly said the video wasn't real. Still, the incident made people who already didn't trust CERN even more suspicious. Even with all these conspiracy theories going around, CERN keeps on working hard to understand more about the world through science. Every time they discover something new, they're pushing the limits of what we know about the universe. But as long as there are things we don't understand and mysteries we can't explain, conspiracy theories will keep popping up, making people doubt even the coolest scientific discoveries. So while some people might be worried about what CERN is up to, the truth is that they're just trying to find out more about how the universe works, one experiment at a time. It doesn't end there. Although science fiends might feel a bit let down by this news, it's important to know that CERN isn't trying to open a door to hell, the future, or any other otherworldly place. Instead, they're still finding those ghostly particles as proton beams race around the 27-kilometer circle of the world's biggest particle accelerator. This might take a while to create a verified theory because the machine is literally buried over 300 feet below the ground. For almost 10 years now, its power to crash particles together at super high energies has let scientists explore the far edges of physics. Recently, the LHC's forward search experiment detector made a really big step forward. It found high-energy neutrinos made by a particle collider for the very first time. It did this super accurately, finding 153 neutrino interactions. This is a big deal in particle physics. It could help scientists learn more about the universe's super-energetic neutrino interactions. Plus, it might help us understand how stars burn and finally explode into supernova. Neutrinos are tiny particles that are almost everywhere in the universe. Even though they're really small, they're very important for how the universe works. Finding high-energy neutrinos made by a particle collider opens up new ways for scientists to make more and better discoveries. Being able to watch and study these strange little particles could help scientists learn more about some of the biggest questions in the universe. By understanding how neutrinos interact better, scientists hope to figure out the secrets of cosmic things like supernovae. They also want to understand how tiny bits of matter behave. This discovery shows the importance of continued research and investment in particle physics. The LHC at CERN has gone beyond what we thought was possible. As our technology gets better and our tools become more advanced, we can expect to find even more intriguing facts about tiny particles. Some people might have been hoping for extremely groundbreaking discoveries from CERN, but the truth is, the work they're doing there is making us understand the universe in very important ways. By considering the tiniest bits of information, scientists are learning the secrets of space, one tiny particle at a time. There's more. Neutrinos are created when atomic nuclei join or break away. They are formed by various processes, including cosmic rays, radioactive decay, the activities of particle accelerators, nuclear reactors, and even the natural radioactivity of elements like potassium found in bananas. Despite being massless and without charge, these particles are like cosmic ghosts. Once they are created, they hardly ever interact with matter. It's estimated that around 100 billion neutrinos pass through every square centimeter of our bodies every second, but they are so elusive that we don't even notice them. This mysterious quality has earned them the nickname ghost particles, and scientists have been trying to detect them since 1956, when they were first observed zipping away from a nuclear reactor. In 2021, physicists finally detected the trace of 6 neutrinos, but it took them 2 years to gather enough evidence to confirm that these ghostly particles were real.
Imagine having the capability of now understanding on a more grand scale, a dimension, 5th dimension, like somebody there obtains the frequency of the 3rd dimension. They can just come right on through.